talking about the importance of soil. So in our canal lining and in our road construction, these compacted soils are going to block the voids. So lesser voids means there is hindrance to the movement of the water through the pores, and finally it will facilitate the drainage of water down into the soil, and it will keep the stability of the subsurface, the grading. The uh, the the first layer next to the road on the ground surface is called grade. So that grade is going to bear all the load, and it will be more strong if the water infiltration is minimum. So that's why we need a maximum compaction of the material. So further we will continue with the sorting. When we have sorted soils, it will be behaving differently, and it will maintain the voids. The voids will not be covered in this case. If we have a well sorted soil structure, for example, we have all the sand in a typical soil layer, it means the voids are not going to be filled with the finer particles, which are clay particles. So that void will be existing, and it will facilitate the smooth flow of movement. So wherever there will be sand, it will have maximum permeability, but at the same time it will have the minimum retention, because there is nothing going to be retained in that typical cross section of sand. So keeping in mind this factor, uh, and we will be talking about a little contradiction, and that contradiction is about the clay layer. If we have a well sorted clay layer, it is not going to facilitate the smooth flow of water, because the voids are already so small that they will not facilitate the water movement. And furthermore, at the topmost layer of the clay, the all the particles of water will work as a surface tension, will create a surface tension, and they will uh, uh, hinder the movement of any further water through that clay layer. So clay behaves differently. If it is 100% clay, it will behave differently as 100% sand. Well, continuing to our subsurface data distribution, we have a very uh, clear distribution between the unsaturated and saturated zones as we defined. And unsaturated means soil zone, and it is also called vadose zone, while the other saturated one is called aquifer or groundwater. So but here we have some of the explanations. So vadose zone, also termed the unsaturated zone, land between land surface and the top of the phreatic zone, that is the position at which the groundwater is at atmospheric pressure. Hence the vadose zone extends from top of the groundwater to the water table level. Here one more thing is important, that is the capillary fringe is saturated zone above the water table, where the water is affected by the capillary force. If you see here, we have a capillary fringe. This capillary fringe is existing in the vadose zone, that is unsaturated zone, and this is created because of the capillary action. The water is rising from this saturated zone, and it is moving upward. It is going in the negative direction. It is going upward to the vadose zone and creating a saturated zone in the layer very next to the groundwater on in the Vadose zone. So here a negative pressure is being created, while on the lower side in the groundwater we have a positive pressure, and at just at the level of the water table we have a zero pressure. So that is atmospheric pressure. So this is something about the pressure distribution. And so this capillary difference is actually due to the capillary action, because the pores are going to work as uh, a capillary tube, and the capillary action is going to be facilitated in that area. Here we have some more descriptions in which we will be defining porosity, and then field capacity, specific retention, specific yield. So if we are going to talk about this uh, volume of soil, you can see that total volume is considered as V. Vp is the volume of pores. Porosity is equal to volume of pores over total volume. So volume of voids to the volume, total volume is going to give us the porosity. It is also uh, now what is the uh, specific sorry field capacity. Field capacity is something about the uh, capillary water plus absorbed water. So this is the water within the pores which is going to sustain in that pore, one pore. So a part of this you can see in this volume of total volume, we can see that this part is the solid part, which is which can be sand, silt, clay, or anything, and it is also having some part which is left with the pores, and this pore is actually sometimes filled with air as well, and sometimes filled with the water as well. So a part of it is having water and the remaining part is having air. So the water which is now existing in that pore will be the water retained in that soil. So that retained water is going to give us the field capacity. So it is kind of specific retention. So it is the volume of water retained in the soil volume. This is the soil volume. And specific yield is the water which is going to pass through those pores. So the water which is Vg is actually the water which is the volume which is not going to exist here. Vg, air or gravity water. So that gravity water is actually the water which is not going to sustain, which is not going to retain in that pore. It will move forward, it will percolate down into the next part, and it will keep moving. It is not going to stay. So the water which can be drained from a soil mass, it will be called as gravity water, and that is the water which is going to be achieved, which can be discharged, and it is going to be called Vg. So this is going to give us the specific yield. So once we go for their definitions, it will be easier to understand what actually it means. So these are the definitions. So permeability is the capability of a rock to allow the passage of fluids, and then we have porosity, we have specific yield, and then we have specific retention. So please go through all these terminologies. These are very commonly known. I think you are already familiar with these terms. We are just repeating these topics. So please go through them, and next time we will continue with this topic, and we will move forward to the groundwater movement, groundwater aquifers. What are the different categories of the aquifer, how it behaves, how the water moves, how we can measure the direction, how we can determine the direction. So all these things will be talked about in the next lecture. Thank you very much.